Ladies and gentlemen, here we go. This is a fun one. We're going to solve this quadratic by completing the square using the quadratic formula. I'm going to go completing the square first, and then I'll show you how the quadratic formula works too. So completing the square, what we want to do is we want to get to where we have our x squared and our bx term sort of isolated and set equal to something. So that's what we're going to try to do here. This is my x squared term. That's my bx term. I'm going to get this guy over to the other side, and then I need to make sure that my x squared is a 1x squared. So there's just a single value there. So first thing I'll do, all right, we'll add 73 to both sides. And let's see, that's going to give me 2x squared plus 16x. Negative 7 plus 63. I think that's 64, but I'm being lazy here. 73. 66. Okay, equals. Okay, so now we need to get this to be a single x squared. So I'm going to divide every single term here by 2. Everything gets divided by 2. Those 2's will cancel, and I'm going to have x squared plus 8x equals 33. Now, I left a little bit of space here. I did that for a reason. When you're completing the square, what I need to do is add some number here to both sides that will create a situation where I can have a binomial squared. So we talked a lot about doing this visually, which means we're going to build kind of a little area model here. I'm going to take my x squared and I'm going to put it here. I'm going to take my 8x and I'm going to split it in half. So I'm going to have 4x and I'm going to have 4x. And then I'm trying to figure out what the number is here that I can add here and here to both sides to complete the square. Well, remember, if this is an area model, right, then it means x times x, right, x times x. X times 4 is 4x. There's a 4 here. 4 times 4 is 16. So that is the magic number. That's the number I'm looking for to add to both sides that will give me a binomial squared, right? This is x plus 4 times x plus 4 to create that area model. So in here I have x plus 4 quantity squared. And let's see, I have 33 plus 16, 49. And this is a very handy number to have right there because that is a perfect square. As I'm solving this, I'm going to be looking to take the square root of both sides. So I'm going to do the square root here. I'm going to do the square root here. And whenever I introduce the square root, I got to put the plus or minus. Arguably, I should have done it on this side too, but since it was canceling out, I wasn't worrying too much about it. Let me slide this guy up. We're going to end up with x plus 4 equals plus or minus 7, right? Square root of 49 is 7. We're one step away from solving for x. I just need to subtract 4 from both sides. So now just to get my two answers, it's going to be x is negative 4 plus 7, and x is negative 4 minus 7. So negative 4 plus 7, x is 3. Negative 4 minus 7, x is negative 11. So these are my two answers, and I get two answers because a quadratic equation is going to have typically two solutions, because if you graphed it, they'd be the x-intercepts, right? And we have a U-shaped graph. So it looks like we're crossing somewhere here at negative 11 and then somewhere at 3. Parabola is going to look something like that. These are our solutions. Now, I did mention a moment ago that you could also solve with a quadratic formula. So I'll show you that here too if you'd like to see. What we're going to do is I'm just going to take that same prompt from the beginning. 2x squared plus 16x minus 73 equals a negative 7. Now this time we need to move this to this side because in order to apply the quadratic formula, this thing needs to be set equal to 0. We need to have ax squared plus bx plus c. So I'm going to do negative 73, and then I'm going to add 7 to both sides. That's going to give me a negative 66. Minus 66. And then I'm going to, because this is in the standard format of ax squared plus bx plus c equals 0, I can pull out my a, b, and c values. I don't have to make this one 1, so it's one less step here. My a is 2, my b is 16, and my c is negative 66. And then I will use the quadratic formula. X equals opposite of b plus or minus the square root b squared minus 4ac all over 2a. You can't not sing it. Then we're just going to plug the numbers in where they go. So I've got x equals, okay, it's the opposite of b. B was supposed to be 16. So it'll be minus 16 plus or minus square root. Okay, b squared, b is 16, so 16 squared, minus 4 times a, which is 2, right? A is 2, times c, which is negative 66, all over 2a, all over 2 times 2. So I'm going to use the calculator to help me out. Now, I highly recommend that you type this part into the calculator first without the square root, just to sort of see what that number is. That number is called the discriminant. The number under the radical will tell you how many solutions you're going to have. I already know I'm going to have 2 real solutions, but if I didn't know that, this discriminant would tell me whether it was positive, negative, or 0. So I'm going to do 16 squared minus 4 times 2 times a negative 66. And that's going to give me 784. So I go here, negative 16 plus or minus the square root of 784 all over 4. Now, square root of 784 hopefully is a perfect square. It is. It's 28. So this is going to be negative 16 plus or minus 28 all over 4. So I'm going to now put these two in the calculator. It's going to be negative 16 plus 28. I'll do that in parentheses. Negative 16 plus 28. Divide that by 4. And there's my first answer, 3. I already knew one of them was going to be 3. And then the other one comes from doing the subtraction. So it's going to be negative 16 minus 28. By the way, you may notice that I'm putting the whole top in parentheses so that I do that addition or subtraction first. And then I divide by the 4. Negative 11. Get the same answers, whether you solve by completing the square or the quadratic formula. If I graph them, these would have been my x-intercepts, negative 11 and 3. All right, hope that's helpful. Message me anytime with questions.